A simple hello, a quick reply, a random thought. You tap send, and within a second, it appears on someone else's screen. It feels instant, effortless, invisible. But what if I told you that in that single moment, your message travels through towers, cables, servers, and even space, guided by systems so complex you never notice them? This is the hidden journey of a text message. So what really happens when you send a text message? The moment you press send, your message stops being words. Your phone converts it into digital data, a stream of binary code made up of zeros and ones. Each letter you type, each emoji, is translated into this machine language. But your phone doesn't send everything as one piece. Instead, it breaks your message into tiny data packets. Think of them like small envelopes, each carrying part of your message. Why? Because sending data in pieces is faster, more efficient, and allows the system to recover if something goes wrong. Now your message is ready, not as text, but as signals. Your phone now needs to send this data through the air. To do that, it uses its antenna to convert digital signals into radio waves, invisible energy that travels through space. These radio waves spread outward from your phone, searching for the nearest cell tower. This happens instantly, even if you don't see anything. Your phone is constantly communicating with towers around you, waiting for the perfect moment to send your data. Your message reaches the nearest cell tower. This tower acts like a gateway, connecting your phone to a much larger system. It receives your signal, strengthens it, and sends it deeper into the mobile network. But here's something interesting. Your phone doesn't just connect to any tower. It connects to the one with the best signal and lowest congestion. That decision is made automatically, in real time, without you ever noticing. Once inside the network, your message becomes part of a massive system. This system includes cell towers across cities, underground fiber optic cables, switching stations, and powerful data centers. Your data packets now travel through this network, moving from one point to another. Each step is controlled by routing systems, which decide the fastest and most efficient path. Your message might pass through multiple towers, travel across cities, or even cross entire countries, all in milliseconds. At some point, your message reaches a server. Servers are powerful computers located in massive data centers. They handle billions of messages every second. Here's what happens. Your message is briefly stored. It's checked for errors. It may even be encrypted for security. If something is missing or corrupted, the system can request the data again, ensuring nothing is lost. Then the server decides the next step. Where should this message go next? If the person you're messaging is far away, your message begins a much longer journey. It might travel through fiber optic cables, thin strands of glass that carry data as pulses of light. These cables run underground, and even across the ocean floor. In some cases, your message may also pass through satellites orbiting Earth. Despite these distances, your message still travels incredibly fast, close to the speed of light. That's why it feels instant. Eventually, your message reaches a cell tower near the person you're messaging. From there, it is sent wirelessly to their phone. Again, using radio waves, their phone receives the signal and begins reversing the process. The binary code is converted back into text. The data packets are reassembled in the correct order, and within a second, your message appears on their screen. What you don't see is everything happening in the background. Systems constantly working to correct errors, manage network traffic, prevent data loss, and secure your message. Even if one path fails, the network instantly finds another. Billions of calculations happen every second, just to make communication feel simple. So the next time you send a message, remember this: that single tap triggered a journey through towers, cables, servers, and satellites across a system designed to hide its own complexity. All of it working perfectly, so you never have to think about it. Because sometimes, the most advanced systems in our world are the ones you never see. And that's exactly where logic hides.